Before leaving this simple amplifier, I'd like to use it to demonstrate a simple graphical technique which can be useful in understanding the behavior of lots of different types of amplifiers, not just transistor ones. This technique is called the load line. The load line is plotted on the device characteristic graph, which is shown on the screen for the transistor we've been using in the last couple of videos. Firstly, consider the extreme situation when the transistor is switched completely off. In this case, IC is equal to 0, and all the voltage from the supply is across the transistor, because VC is equal to 10 volts and VE is 0 volts, so VCE is equal to 10 volts. We'll plot this point on the graph as point A. Next, consider what happens in the other extreme situation when the transistor is fully on. Now IC is limited only by RC. I'll plot IC in this situation on the graph as point B. IC is equal to VCC minus VE over RC. So in our design, IC is equal to 10 volts divided by 5K, which is equal to 2 milliamps. Now draw a line joining these 2 points. This line is known as the load line, and as a signal is applied to our transistor, we move up and down the line. It shows us exactly what voltage and current to expect across the transistor and through the transistor, and also the base current which is causing these. We can mark onto the line the current at which we biased the transistor at, which was 1 milliamp if you remember. This, of course, is the point on the load line where the device sits without any applied signal and is called the quiescent or Q point or bias point. I'll mark it on the graph as point Q.